Hello guys. So I'm gonna speak into the mic. So we're gonna do Diffie ASMR. I'm just kidding. We are going to do some differential equations, and this is my first video. So I'm going to walk you guys through an example problem of a spring mass system that was on a previous university final. Yeah, let's get right into it. Consider this spring mass system with n equals 6, with the mass, so 6 kilograms, c equals 3, and k equals 1. And we're given this external force, and we're trying to find the general solution for the position function. So on my final, I was given a cheat sheet. It breaks it down into 4 different types of problems with this. So you have the free motions, and then there's also force motion. So for this problem, we're gonna go into this category, and then we're gonna check if it's underdamped or damped. So with this problem, it's gonna be damped, I'm pretty sure, yeah. So it's damped. So looking to this, so I would highly recommend having some sort of like screenshot this or copy it down into your notes to practice with if you don't have a formula sheet for your final. But this was very useful when I took my final. And so we're looking into category 4, and basically it gives like a breakdown into how it works. So you use this equation. Okay, so essentially this is what the equation should look like if you picked the right category. So I'm going to fill that out here. So it's going to be 6x double prime plus 3x prime plus x equals 2 cosine t over root 3. So this is our differential equation. And from here, I like to do the characteristic equation next. So I'm just going to write over here, characteristic equation. Okay. And then it's going to be 6r squared plus 3r plus 1. And then set that equal to 0. And then we can get r from here using this equation I wrote down here. So it's going to be negative c plus, I'm just going to copy that down. And this is actually going to be equal to r equals negative 3 plus or minus the square root of 3 squared, which is 9, and then minus 4mk, so negative 4 times 6 times 1, so it's going to be negative 24 all over 2 times m, which is 2 times 6, which is 12. So now that we got r, it sets the basis for our characteristic equation. So what you get for this is very important. So making sure you do the math right here correctly and making sure you didn't make any arithmetic errors, super important because it sets the basis for the rest of the solution. Okay, so now I'm going to move on to that actual characteristic equation using the roots that we found. So for the characteristic equation, we're going to use, it's going to be e to the whatever we found right here. So it's going to be e to the negative 1/4 t. And then we're going to multiply that by cosine root 15 over 12 t. Ooh, okay, yeah. Plus sine root 15 over 12t. So we use those roots to make our characteristic equation over here. And of course, we're going to go add in our c's. So c1, forgot to add these in. So negative 1/4 t, and c1 cosine root 15, and then c2. So I went ahead and color coded where I got the negative 1/4 and the root 15 over 12 from and where you put them in that characteristic equation. So now I'm going to move on to the particular equation. So for x of p of t, we're going to use the original external forced equation. So f of t equals 2 cosine t over root 3. And what we're going to use from that equation is the 1 over root 3. So I think I'm going to highlight that in a different color. So this 1 over root 3. So whatever is in front of that t in the external force equation, so we're going to be using that. A cosine t over root 3 plus b cosine t over root 3. Over root 3. And when we're making the particular equation, we're also going to be keeping in mind that we're using both when there's like trigonometric function like sine or cosine, we're going to be using both sine and cosine in these. So when you're writing these particular equations, you have to make sure to use sine and cosine when doing the particular equation. So the next step would be to be finding the first derivative and the second derivative of the particular equation. So I'm going to go ahead and write those out because I trust you guys know how to find a derivative of equation. So this is what I found for the derivative and, well, x prime and double prime of t. Substitute all of these equations, so all of these particular equations, into here and equate it to this equation. So the external force. So I am going to write that all out for you guys and not waste your time. I just realized when I was writing this down, I meant to say this equation and not this equation. So make sure to not do the same as me because then you would forget the original particular equation. So yeah, and then I'm going to equate all of that to this forced motion. And just to clarify, I color coded all of these equations where they are here and where I got them from. So the orange is the double derivative. I literally colored, so that's not what I meant. Okay, this is why you double check your work. So this one is from here. The pink one is the first derivative. Then the orange one is the second. And I think personally what took me the longest on the final to do was this stuff right here, like simplifying all of these, like distributing that 6, distributing the 3, and then like adding up the like terms. That took me the longest on the final. So doing this stuff really, really fast and like knowing it intuitively and practicing over and over and over again, it's going to save you so much more time to do this on exams. So tip right there. So, and I'm also going to just simplify all of this for you guys so you don't need to watch me do that. Okay, so this is what it should look like when you simplify it. And so this is from particular x d of t. And then this is the forced motion, so what they give you in the problem. So it should look something like this when you're doing a problem, like a mass spring problem that is damped and with forced motion. So from here, in order to solve for A and B, it's just algebra. So we have this term over here. We have this term in common, t over root 3 cosine t over root 3. So we can equate the negative 3b minus a to the 2. And since there's no term like this on the other side, we equate this negative b minus root 3a to 0. And from here, I'm going to solve for b first. So in this equation right here, we have this advantage that there's a 0. So I'm going to say I'm just going to add b to both sides. So b is going to be equal to negative root 3a. And so we already got b in terms of a. And so we can substitute that into the other equation. So substituting that into the other equation, so it's going to be root 3 times negative root 3a, yeah, minus a equals 2. So this is just going to be negative 3a minus a equals 2. So this is negative 4a equals 2. So a equals negative 1/2. And then we can substitute that a back into here. So this is going to be b equals root 3 over 2. So now that we have a and b, we can substitute that back into x of p of t. So in order to find, the question was asking for x of t, and x of t just equals x of c of t plus x of p of t. So the characteristic equation and the particular equation. Okay, so therefore x of t equals this whole thing right here. And yeah, I hope you guys enjoyed the video.